Today I will show how to solve question number 1 for the pair sample test using Spss, and I already opened it. And for the first step, he's setting up the variables in the variables view. As you can see on the screen, for the variable I type before and after for the name, and the type I use the numeric, and label I'll type knowledge score before program and after program, and after that the measure I using the scale. And next, in the data view here, I already enter all the 12 participant knowledge score for both the pre-test and post-test, means before and after. And for the question number 2, what is the dependent variable? What is the dependent variable and the independent variable? The dependent variable is the HIV knowledge score, and the independent variable is the health education program. There is comparing scores before and after. And for the question C, state the hypothesis. There's the hypothesis that there is no significant difference in average HIV knowledge score before and after the program, and the alternative hypothesis state that there is a significant difference in average HIV knowledge score before and after the program. And question number D, perform normality test. What type of the test will you perform for the above data? And now for the question D, we need to test for normality before picking the right statistical test. We back to the Spss data editor. We click to the transform, and we're going to compute a variable and type diff as the target variable, and we type the after and before in the numeric expression. Then click OK. And next we click the analyze and going to descriptive statistic, and after that going to explore. And we click the plot here. We check the normality plot with the test. Click continue, and we continue it. The Shapiro table in the output. Okay. And it's 12. The value is greater than 0.5. Yeah. This means the different data is normally distributed. Therefore, the parametric Okay, finally for the question E, I will run the test by clicking the analyze and compare means and proportions, and going to pair sample t-test and select before as a variable 1 and before variable 1 and then after variable 2, and we click OK. Okay, the point to the pair sample test output table is here. Here. And interpreting the result. The mean score before the program was 60, and after the program it increased to 68.83. So for the conclusion, since P minus 0.05, we reject the null hypothesis, and this proof here and here we can see all the result. This proof there is a statistically significant increase in participant HIV knowledge score after attending the health education program. That means the program was effective. Thank you.
Moving on to the question 2, we went to determine if there is an association between percent change in oxygen consumption and percent change in the plasma neuropilin across 70%. First, we enter the 75 of value into SPSS under data view, setting both variable as a scale measure. Our null hypothesis states that there is no significant association between oxygen consumption and neuropilin level, while the alternative hypothesis states that there is significant association exists. To verify our assumption, we conduct a normality test using analyze, descriptive static, and explore and select normality plot with test. Running the test under analyzed corrected brevet gives us a Pearson correction coefficient of R 0.50 with a total p-value less of 0.005. Manual calculation. R is a 0.850. T-test (15), p-value more than 0.001. Result R 0.850, p more than 0.001. Conclusion: because p more than 0.05, we reject the null hypothesis. There is a statistically significant, a strong positive correlation between percent change in oxygen consumption and percent change in a plasma neuropilin. Thank you.
Hello, my name is Alafik bin Alias, and I am one of the group members of this SPSS assignments. So, for my part, I am responsible for question number three, which compares the mean enrollment between research medical schools and primary care medical schools. Since these are two separate groups, and this question involves two independent samples, and my task is divided into four parts. First, I will show how the data are entered into SPSS. Second, I will state the hypothesis. And third, I will perform the normality test and identify the appropriate statistical test. And finally, I will conduct the statistical test using SPSS and explain the results. So in part A, we are setting up our dataset in the SPSS. And because we are comparing two independent groups, we will set up two variables in the SPSS variable view. So the first variable is the sorry, enrollment, which is numerical and is measures as scale. And the second variable is the group variable. So it's numeric and measures is nominal. So under the values of group, okay, number one, we're going to represent research, research, and the second is to represent the primary care. So, okay. So we're gonna reduce this decimal places into zero and okay, and in data view, we're going to stack all the enrollment values into a single column, tagging each with its corresponding group code. Okay, so I'm going to key in all the values here. Okay, so I have key in all the data from the question uh, that given. So these are all the values. Uh, we got 33 data points, and each of this value, the enrollment value, it has its own group code, which now uh, one for research, and number two is primary care. So for part B is a state the hypothesis. We define our null and alternative hypothesis. So the null hypothesis states that there is no significant difference in the mean enrollment between research and primary care medical schools. And the alternative hypothesis states that there is a significant difference between the two population means. So now we're moving on to the part C, which we are required to perform normality tests. So to determine if our data meets the parametric assumptions, we will perform the normality test. So in the SPSS, I'm going to choose the analyze and then going to the descriptive statistics. I'm going to choose the export tab. So we see here there are two the variables and the enrollment. I'm going to add in the dependent list in the group. I'm going to add in the factor list. I'm going to click plots. Then I'm going to choose the normality plots with test and click continue. And then, okay. Okay, as we can see here, since the group is less than 50, so we're going to use the Shapiro Wilk test results. So for the research group, the p-value it was 0.881, and for the primary care, the p-value is 0.993. So both of the p-values were greater than the 0.05. So therefore, both groups were considered approximately normally distributed. So since the data were numerical, the two groups were independent and the normality assumptions was satisfied. And the appropriate test was the independent samples t-test. So the last one, the part D, going to perform the statistical test using SPSS and interpret the results. So finally, for the part D, we will perform our independent samples t-test. So in the SPSS, we're going to click the Analyze tab, and then we're going to compare means and proportions and select the independent samples t-test. So we place the enrollment into the test variable box and group into the grouping variables. Um, so make sure that the homogeneity of variance test option is checked so that uh, the Levene's test appears in our output table. So once generate to define groups, okay, and then continue, and then so as you can see here, first we look at the Levene's test for equality of variance. It's over here. The Levene test for equality for variance. So for enrollment, okay, guys. So we see here if the p-value for the Levene's test is greater than 0.05 and the variance are equal. So we read the top row equal variance assumed. If the p-value is 0.05 or less, 0.05 or less, the variance are not equal, so we read at the bottom row. Equal variance are not assumed over here. Okay, so we read at the top row. Okay, so next we check on the significant to tell. It's over here, and then um, significant for to tell. If the p-value is less than 0.05, we reject the null hypothesis, concluding there is a statistically significant difference in mean enrollment between research and the primary care medical schools. If it greater than 0.05, we fail to reject the null hypothesis, concluding there is no significant difference. So that completes the analysis. Thank you for watching.
Okay, for now, I'm going to answer the question 4. Question 4 is about a researcher would like to see if there is significant difference in the means of length of different types of bridges. The diagram represents the length in feet of 3 types of bridges in the US as follow in the table. Okay, for the question number 1 is for me to key in the following data in SPSS and save the data in my answer. Okay, to key in the data in this SPSS, we need to go to the variable view, and in the first column of name row, we type reach, and the second one we will type length, oh shit, th. Okay, for this one, we need to set the value 0, all is here, and then value 1 for simple trust, then get on another one, S2, segmented, call 3. The last one is value number 3, 20, click reach. Okay, so in the data view, it will be like this. Okay, in data view, you key in our data. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Trust, then the business 2, 3, 12, 12 segmented, 3, 4, 5, 6, 7, 8, 9, 10, 11, 3, 4, 5, 6, 7. Okay, 12, and we key in the length, this one, simple trust, S745, 716, 650, 67, 65, 6, no, 608, 598, 550, 545, 534, 528. Okay, this one is for the segmented row, P820, 750, 790, 674, 660, 640, 636, 620, 520, 450, 392, and 370, and 631, 420, 480, 460, 455, 450, 450, 425, 420, 360. Okay, now we finish getting the answer for the question A.